Okay.
Okay.
So for 1, I came up with A.
You mean for
We are 90%, I'm sorry, for number 2, that we are 90% confident that the true mean heart rate is between 45 and 105.
Yep.
Yeah, that's
Okay.
what I had to.
Okay, good. Because it's not the chance ones, and it's not the 90% of all people have a heart rate between 45 and 105. So, okay. Researchers at the university, blah, blah, blah. So the researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they create QQ plots of both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? So this went back to one that I got wrong, I think, last week. But I put it's D.
So I actually put C, but let's figure out why.
Which one is that on this? Let me see.
Oh, so mine are in the same. So it's no, the distribution means. Right. No, the distribution of means for each sample is not normal since the sample size is not large enough. But if it's saying that the QQ plots, I didn't catch this the first time. If it's saying that the QQ plots and the histograms were normal.
Yeah. My answer was actually B on this one. It was yes, the distribution of the mean of each sample is normal since the data have been determined to be normal. Because that was the correct answer on another one that was similar to this, but
That will be right because the assumptions for confidence intervals are that it's a random
yeah.
sample.
And if you can determine that it's normal with the QQ plot.
Yep. And
so
then the sigma is assumed to be known, and they don't tell us that or not. But.
Yeah, so I have the yes, the distribution of mean. Is that okay, Phil, or?
Yeah, that's what I got.
That's what you got. Okay. All right. They're matching up so far. I'm just worried that they're going to be out of order, and all I wrote was the letter that I chose, like in some of them. So, okay. So of the 4 type of confidence intervals listed below, which one is appropriate for this experiment? I put D, which is the confidence interval for the difference of means using independent samples.
So I had a question on this. I don't know if it was the confidence interval for the mean when U is unknown, or if it would be the confidence interval for the difference of means, or the D, like you were saying. So what's the difference? So we know, is this a
well, they're doing 2 different they're comparing 2 different means, aren't they? So I figured it would be between especially with the answer from number 3, I figured it would be between the paired, the dependent and independent.
Yeah, you're right. It would definitely be 2 different means.
Yeah.
So it wouldn't be the known or unknown. So
yeah. But because they had to find that each of the means were normal, they had to create a QQ plot for each of them. That goes along with the independent one.
Well, that would be for both, though, wouldn't it? Whether it's dependent or independent, the QQ plots would still have to be normal.
Well, I think for the paired one, you just do the difference column, but with the independent, you do each one. See, that's what I went to the meeting for the other day, is because I was trying to figure out, I have a hard time telling the difference between the paired and the 2 sample means.
For this one, I'm thinking it would definitely be independent because just because you pick a male doesn't mean that the female is automatically determined.
Exactly.
It's a random female. They're
Yeah.
not related, or they don't have to go to
Yeah.
school, or whatever.
I was just gonna say that.
Yeah. Okay, so that's what I came up with too. So we're all in agreement of independent?
Yeah.
Yeah.
Okay. All right. Yeah, I still have a hard time though. Like several times I wish they would just do multiple choice because it would help me to know if I'm just completely in the wrong test or ballpark, like, but
Yeah.
I won't count on it. Like I liked this practice one because it's all multiple choice, but it's
Right.
Okay, so five. A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be $3,402.08 and $4,142.75. Which of the following would produce a confidence interval with a small margin of error than this 95% confidence interval? So from what I understood from all the lessons is that you'd have to increase the sample size to
Well,
to,
the sample size, if you get the confidence interval gets smaller as the sample size grows, but the margin of error, if we want a smaller margin of error,
mm-hmm.
we have to actually increase the sample. Oh wait, that is good.
So we have to what?
Okay, we have to increase the sample size in order to get a smaller margin of error. Sometimes I confuse myself in how I'm trying to.
Oh, okay. So if you obtain the balances of 90 bank customers rather than 30, is that what you guys got, or did you get something different?
Yeah, that's what I put. But do you think this could be, what are the
That was
other
awesome.
obtain the savings account balance of only 10? It's definitely not less. Compute 99% confidence level. So if you change the confidence level, what does that do?
That would do
A
it too,
smaller
wouldn't it?
confidence level is equal to a more narrow confidence interval. That's the opposite of what we want to do. We would want to go 90. But it's got to be the second one.
What did you want to say, Phil?
I was just thinking about the 99 and how if it grew, it would make the margin of error smaller, but I don't think that was right. So I think it's the give
Yeah.
the bank customers.
Yeah. So if it's the larger the confidence interval is,
Mm-hmm.
bigger the interval is, because it's a so if we wanted to make the interval smaller, we would want to go 90% confidence interval, not up.
What's the margin of error formula to figure it out?
It's m equals 2 times the standard deviation over the square root of the number.
N equals 2 times?
Yes. No, m equals 2 times the standard deviation divided by the number, the square root of the number.
But we don't really know what the standard deviation is on this or the number.
No, we don't.
We
But,
could make one up and see what happens.
yeah, because we're just comparing. That's true. Because we're just comparing whether. But I know for sure that if we increase the sample size, then our margin of error, our interval width, will also get smaller.
Okay.
2 is definitely correct. And I think 3 is not correct, because in order to get a smaller interval, we want to go down, not up on the
Okay. So, okay. All right. So we are confident about the 90 bank customers rather than 30?
yeah.
Okay. All right, 6. A factory makes propeller drive shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds the sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shafts. So for this, I got the formula of you take like the 1,000 and you subtract 1.96, which is the 95% confidence interval number, and then you multiply that by the standard deviation over the square root of the sample, which is 4, and then that gives you the low end, and then for the high end, you take 1,000 plus 1.96 times 2 over the square root of 4, which is those are the standard deviation and the sample number.
Out by hand yet. I haven't done that one yet by hand.
Okay.
And then
I just plugged it all into my Excel sheet, and I'm just going to save my calculations, like my Excel formula, so that I don't have to set it up again. Just can enter in the new numbers.
it was 2 millimeters. And what was the number? How many samples were there?
There's 4, I think. Let's see. She randomly selects 4 drive shafts made at the factory, so 4.
1,000 plus or minus 1.96 times 2 divided by 4. Oh, square root of 4.
Divided by the square root of 4.
Okay. So,
And did you get this one, Phil?
Yeah.
Yeah, I think I got a pretty definitive answer. At least it showed up in the multiple choice. So.
Yeah. That's
Yeah. That's why I like the multiple choice. I'm like, can they please do that on the chapter unit quiz? That would be great. Just so I know, because there was like some that I was like completely in the wrong ballpark, and that's what I need to talk to the teacher about. Is because if you just copy and paste some of the data from those files, it doesn't unless you manipulate them a little bit. It doesn't always give you the right numbers.
Mm-hmm.
okay.
Okay.
I emailed him too.
Did you?
And he sent me back an email saying he checked my numbers and I was completely off, and it's just under my own understanding. And I was like, what? No, I put everything in the way it should have been.
Yeah.
And I still got it wrong. So I think.
Okay, so I'm getting the first one.
That's what I got.
Yep.
Okay. All right. Okay, it says 7. To assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with an unknown mean and a standard deviation of 0.01. How large should n be so that a 95% confidence interval for the mu has a margin of error of plus or minus 0.0001. So this is the formula where you take like the z times
Standard deviation.
Standard deviation over m all square, to the square. Yeah, so
that out real quick. Hold on. So we've got we don't have that. So did you have to look at the applet to find the z? Yeah, because you would have.
Actually, I didn't. Well, maybe did I? Let me think. Did I? No.
How would you?
No, because we already know it. It's 1.96, isn't it?
No. Oh, was it? Oh, I thought you could. When we plugged in a little bit.
It's the 95%, so it's the 1.96 number. And then you multiply that by the standard deviation, which is 0.01, and then you divide it by the M number, which is 0.0001. And then you square that all.
Oh, yeah, you're right. Okay, so 1.96 times, oh wait, but, oh yeah, times 0.01 divided by 0.0001, and then we square all of that. Okay.
I got 19.6.
No. Maybe you need to put some of those in parentheses.
Well, I do them each individually, so.
Hmm.
So it's the 1.96 times 0.01 divided by 0.1 or 0.0001, all square rooted.
Yes.
Yeah, so you'd have to, how I put it in Excel is you have to put parentheses around the 1.96 and the 0.01, like the multiplied by that, and then you have to put a parenthesis around the whole equation from that to the 0.0001. So, and then you square root all that, or I mean, put it to the second power. So, I come up with Excel calculated it, and I got 38,416.
That's what I got too.
Oh, okay. But let's make sure Phil gets the same thing before we move on.
If nothing else, make sure he knows how to do it right.
Yeah. Well, and I could be wrong, so that's why I'm like, let's make sure we're all like getting the same answers before we move on.
Okay, so tell me if this looks right.
Okay.
That one.
Oh, I'm looking. Hold on. Okay, let's see. Oh, I can't see it.
No, it doesn't look correct. So you have to multiply 1.96 by 0.01 before you square it.
Yeah, that should be together.
Okay.
And then
so
that whole thing is divided by the 0.0001.
The squaring is the very last thing you'll do. But in this, but it's not the square root of, Phil.
It's not this. Yeah, it's like to the second power.
Oh my gosh! Yeah. Okay.
It's squared.
That was dumb of me. Hang on, just 1 second, guys. I'm sorry.
It's okay.
How did you get your written stuff on the computer?
I just put it up to the camera.
The camera?
Yeah. $38,416.
Yep.
Yeah.
Okay.
Good. Yeah, when I went to the meeting the other day, I'm like, like all of my mistakes are they're just such simple little errors that I don't know that there's any way for me to correct that for the quiz, and that's what makes me nervous about it. It's just there's no way to know if I'm like, because it's always one or the other with me, and so usually I'm like kind of stuck between the right answer or the right direction and the other way. But yeah, I don't know. I'm like worried. I'm like, I really need a better grade on this one.
Yeah, that's for sure.
Okay. So it says the mean area of several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised, so that's less than. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypothesis is that, and this is where I answered the A. So the mean HO should be mean equal to 1250, and the alternative hypothesis should be the mean is less than 1250. Did you guys get the same thing?
Yeah, I did.
Okay. Some of these I went over really quickly because I just thought I had them, so I'm like, I could completely have made an error, so it's nice to be able to compare. Yeah.
I do that all.
Yeah.
I know what they're asking.
Yeah. Okay, so in a statistical test of hypothesis, we say that the data are statistically significant at the level of significance alpha if alpha equals, and I think it's the p-value is less than the alpha. Is that what you guys got?
Yes.
Okay.
Because the only time you ever say it's significant is if you
reject the
reject the null, and you have to
null.
reject with less. Yeah.
Yeah. Did you get the same thing, Phil?
Yeah.
Okay.
Because that's the whole rejecting the
Yes.
null hypothesis and all that jazz there.
Yeah. Okay, a group of statistics students wants to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample size of 15 from each of the 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample standard deviations are nearly equal. Can they use an ANOVA hypothesis test to answer their question? I put a question mark. I guess I didn't really know. I figured it was if it is enough that the data are bell-shaped with no outliers, that because that's one of the requirements of an ANOVA hypothesis test. But I don't know. What do you guys think?
Well, there's 15 samples for 4 different groups, so I think that's right.
Yeah.
For each apartment building are bell-shaped with no outliers.
I mean, their sample size is kind of large. I mean, small for each of the samples, but we've noticed with the ANOVA that tends to be the case. But as long as they are determined to be normal, you can go through each and do a histogram or a QQ plot or something. And as long as they are determined to be normal, then you can proceed.
I would think, yeah, it's A.
Okay.
In order to use the ANOVA test, they have to either assume that they're approximately normal, which they are because it's a bell shape,
Mm-hmm.
That they have equal variances.
Mm-hmm.
And if their standard deviations are nearly equal, then they're going to be nearly equal.
Yeah, they're not going to have the 4 times, and that's where that variance comes in, or the standard deviation. It has to be 2 times, but if they're all nearly equal, then they're going to be good. So,
can you explain to me how that whole 4 times or 2 times, that formula, you multiply those numbers together to see if it's normal or not normal?
Yeah, I mean, you just take the
the smallest variance is 4 times the largest, or no, wait, other way around.
The largest would have to be 4 times, and you can kind of visually look at it and see that, sometimes.
But I mean, if it is 4 times, then it's normal, or it's not normal?
It's not normal.
Okay.
Mm-hmm. Yeah.
So we want it to be less than 4 times
Mm-hmm.
in order for it to be normal.
Right, or less than 2 times on the standard deviation.
Okay, that makes sense.
Mm-hmm. Yeah.
Sorry, a little side thing.
No, that's why I think we got the one wrong on the quiz the other day, is because we understood it, like we're like, oh yeah, you know, it's not more than 4 times, but then we put the wrong answer. I don't know, we didn't really look at that carefully. So like we got it, but then we didn't get we didn't mark the right one. So yeah.
That makes sense.
Okay.
Yes, that the data are bell-shaped. That's what I'm thinking.
Yeah, the bell shape with no outliers. Yeah.
Okay.
I think that's it, because it's not number 2. I mean, it could be number 2, but it's individual.
You couldn't even apply the central limit theorem, though, because there were only 15 samples from each.
Yeah, and each one. And then, no, they don't have enough data. Well, yes, they do. I think they're fine.
Yeah.
And no, they do not know the true standard deviations of each sample. And I'm like, well...
We know they're nearly equal. We don't have the exact number.
Yeah, exactly.
Okay. All right. Moving on. So...
A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tells the new treatment tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05% significance level. Consequently, she rejects the null hypothesis. In the future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The researcher has... Okay, so I went back to my little chart.
Yeah, that's what I'm doing. Okay.
And she rejected it. So that takes us down to the bottom. She rejected the null hypothesis. Is that correct?
Yeah, because she's, even though the sample size is small, the null hypothesis would be rejected. So yeah, we're on the bottom column then.
And so I would think it's the type 1.
Consequently, she rejects the null hypothesis. In the future study, it is determined that the new treatment. So, but it is true or it's not true. Even though, so the null hypothesis is that the survival time, the average survival time diagnosis is 2 years. In an early trial, she tried. So how do we know if it's true or false? I thought I read that somewhere in the very beginning.
Yeah, I thought so too. I mean, she did the null hypothesis was.
Oh, it's the second sentence.
It's 2 years. Yeah, the null hypothesis is 2 years, and she found that when she did the new treatment that it was a 4.5 year time span. But she had a small sample.
Well, so at the beginning, though, she was saying that the null hypothesis is that the average survival time after diagnosis. So.
Oh no, my brain honey just crashed.
Oh no.
Hopefully it will come back up while we're doing this so that I can submit this.
When my computer turned off a couple weeks ago for that update, it did pull it back up.
Okay.
So hopefully it'll come back up.
Yeah, it just won't let me log in again. So it says it's unavailable. So.
Oh, it let me log in still. Like, oh, it's probably because this is the. Well, it was the same thing though. Group meeting.
Yeah. Yeah, it's been crashing on and off all week. The Brain Honey has been. They're having problems with it, I guess. Okay, so I'm sorry. So she rejected it. So we're in the bottom column, and if the null hypothesis was false, then it would be correct. If the null hypothesis
Was true, which
was true.
Because it was equal to.
Uh-huh.
And she rejected it anyway. Wait. Average survival time after diagnosis. I don't know. I'm thinking it's type 1 error, but
Yes, I am too.
but because I've never seen one like use where it has anything to do with the misuse of the significance level.
Yeah,
so those
well,
were out to me.
I mean, that's how you determine whether you reject or fail to reject the null, is it by the significance level. So she found that it was significantly significant because it was 4.5 years. But it finds that later on they determined that it was not, that the null hypothesis, that this new treatment doesn't increase it, and so that the null hypothesis was true. Yeah, okay, it is type 1. So the null hypothesis was true because this future study determined that it was, but she found a significance in her studies, a significance level, and so she rejected it. So she committed a type 1 error.
Okay, that's what I'm thinking.
Yeah.
But I hate these questions.
I know, they're so confusing. Oh, I hate them. Okay.
Even staring at the little, chart.
Yes, me too. Me too. I'm gonna have to make sure that's on my my little cheat sheet.
Yes.
So my notes, my 1 page of notes. Okay. All right. So D, or 11. No, it's not 11 on this one though. It's 12. Okay, 12. I have D.
I have.
Oh yeah, because by reducing one, you increase the other. So by reducing the probability of committing a type 1 error, we increase the probability of committing a type 2 error.
Yeah, that's what I have too.
Okay. I remember those are the opposite.
Yeah.
Okay, so, and Phil, if you have something different, please, let us know. We're just like,
I have such a hard time with the type 1s and type 2s. I have no idea which ones are which. So
you really just go to the go get that little chart from which chapter was that in? I think it was like chapter 1 or 2. I mean, not 1 or 2, 10 or 11. Where is that? Okay, I think it's 9. Chapter 9. So it's chapter 9.
okay.
There's a little chart that, does the whole failed, the type 1, type 2. It's like reject, fail to reject. But
okay.
But you just go by that. So if they're failing to reject, then it's probably going to be a type 2. It's either that or correct decision.
And it wasn't correct.
Yeah.
Okay.
At the very least.
Yeah, I have such a hard time with those because I get so confused.
Yeah, very confusing. Okay, so for 13, the nicotine content in cigarettes of a certain brand is normally distributed with a mean in milligrams and a known standard deviation of 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5, but measurements on a random sample of 100 cigarettes of this brand give a sample mean of X bar 1.53. Is this evidence that the mean nicotine content is actually higher than advertised to answer this test the hypothesis. So they kind of give us the hypothesis, which, you know, the null hypothesis is that the mu is equal to 1.5, and the alternative hypothesis is that the mu is greater than 1.5. So, so with this one, this is the x bar minus the mu divided by the standard deviation divided by the square root of the sample. Is that what you guys got for the formula?
Hold on. Sorry. Wait, what formula did you? So we want to use the.
I have the test statistic formula. So the x bar, which is 1.53, minus the mean, which is 1.5, divided by the standard deviation, which is 0.17, and that's divided by the square root of the sample, which is 100.
100, yeah.
And
let me work this out.
And this is where, yeah, this is where you have to use the normal probability applet, I think. This is why I'm like seeing if.
Why would you need to use the normal probability applet?
Well,
I didn't use the test statistic formula. I just like reasoned it out in my mind. But I want to see if it changes if I actually do the formula. So hold on.
Yeah, well, the reason I did the normal probability applet was to find the p-score, the p-value. And that's what we base whether we reject or fail to reject.
That would make sense.
Yeah. So I got, go ahead and work it out, but I have that you reject the null hypothesis, which is D, but let's see what you guys get.
Okay.
So I took the number from that equation and put it in the normal probability applet as the z-score. That's right, right?
You took which one?
So I got 1.764 from that equation.
Yeah, and I rounded up to 6.5, but yeah, that's what I got.
And then, oh yeah. But I put that into the as the z-score for the normal probability applet, right?
Yes.
Yeah.
And then the area above that is what it is.
So, remind me again, what are we supposed to be, what area are we supposed to be selecting on this?
It's greater than, so it should be everything to the right of the positive z-score. So 1.765 is a positive number, so it should be everything to the right of that. That's what I thought, but
this is where I always confuse which area to state on this.
yeah, it's greater than, so it's going to be everything to the right.
Just to the right.
Mm-hmm. Of that positive z-score, yeah. So everything to the right of the red positive line.
Wait, is it a z-score though, or is it a? Oh, because our z-score is positive, we just want the right. Okay.
Yeah.
So 0.0401 with right.
Well, the 1.765 is our z-score that we got from the test statistic.
Sorry, I missed a decimal in that.
Okay.
1 point. I just put 1.75.
65.
So 0.2221.
No.
No, I missed the 1 now. 1.765. Okay, 0.0388.
That's what I got. Okay. Did you guys get the same?
Yeah.
Yeah, Phil, you got 0.0388?
Yep.
Okay.
Yep.
So because that's less than the 0.05,
So that area is our p-value.
Yeah, just to the right because we're looking for greater than.
I've never made that connection before.
Mhm.
So that's our p-value. So that would be less than, so we would reject, right?
Yes. The HO. Reject HO. It's D.
Oh, we would reject HO?
Right, because they slipped in there rejecting the alternative, and you never reject alternative.
No.
Oh.
We're rejecting or failing to reject the null hypothesis, which is HO.
Sneaky, sneaky.
That was sneaky. Okay. So that area is the p-value. How did I never make that connection before?
Which one? What do you?
So when we're selecting on the normal probability app, wherever we're selecting, that's the p-value that we're determining.
Yeah, I mean, because if you shade, you're going to notice that the p-value changes. Like if you shade more areas, it will, like I shaded the middle and the top, and it gives me 0.9612. Like it's going to completely change the p-value based on where you shade.
I guess I just didn't realize that was the p-value, or I'd forgotten. I don't know.
And if you do like the two-tailed test, which we do like in later chapters, like it gives like the like a 0.0776, but we're not doing not equal to, you know, we're doing the greater than. So yeah.
So it's just that one side. Okay.
Just that one side. And if you were trying to do like if you got a negative z-score, like a negative, and it wants to know the greater, then you would go middle and the top. So it would be everything to the right. But if it's less than the negative z-score, it would have just been that little small left tail.
Okay. It's all starting to click now.
Okay.
That portion of it, right? Okay. Are we on 13 now?
Yeah, or 14 in the test. Okay, so you would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? Okay, so I did the paired because they're from the same.
I did independent, and it was because okay, let's think this through. If you'd like to look at the mean number of hours worked by male students and female students, you would like a random sample of 100. Yeah, I did independent because by picking the male, it doesn't automatically tell you who the female should be. It just, so they're independent.
Okay.
Does that make sense? What do you think, Phil?
That makes sense to me because it doesn't matter which male you pick. The female can be different or whoever.
Right.
Okay.
And I thought the paired had to be like that couple's example where you pick the husband, you pick the wife.
You know who the wife's going to be, right. So like for this one, I was thinking, okay, if you have a massive room of people, right, and you pick like Tom, it doesn't mean for sure, it doesn't mean that the girl is going to be a Stephanie. Do you know what I mean? It's any other girl.
Okay. So independent sample t-test?
Yeah. Or no, just independent sample test. Is there a t-test? It's not a one sample. They're not one samples because we have
It's
two.
one sample z-test, one sample t-test, paired sample t-test, independent samples t-test, and then ANOVA. That's the choices.
So I'm thinking independent sample test.
Yeah.
Or independent sample t-test.
Yes. Yeah, that sounds fine. I like I told you, this is where I keep getting confused. I cannot tell the difference. Like, the teacher tried to explain it to me. I'm trying to use the logic, and I can't get it. And I'm like, unless I get like a bunch of these for practice, I don't think I'm gonna get it in time for the quiz. And there's just no way to
Keep thinking. Keep going back to like the married couple.
Yeah.
If they're literally connected, like connected in some way where there's no question who
Yeah.
know one, then you'll know who the other one is. But in this
Yeah.
situation, knowing one doesn't tell you anything about who the girl's going to be.
Mm.
Or vice versa.
I think there was one in the homework quiz that was just so confusing. It really, I didn't know if it was one or the other, so I didn't see the connection. So I think I chose like the independent, but it was really paired. So anyways, I'm keep getting confused by these.
Yeah, just try and get as many. Maybe Google like.
Well, one thing he told me was that, but it doesn't help on a question like this. But if the data is equal, then it's going to be more than likely a paired sample t-test. Whereas if the data is like equal as far as in samples, but if the one category has like 20 and the other one has like 15, then it's more likely going to be an independent. So that's something he told me.
Because if you have husbands and wives, then if you have 10 husbands, you're going to have 10 wives.
Yeah.
But if you have, like in this case, students, if you have 10 males, it doesn't mean that you're going to have 10.
Right.
You might have.
Right. So I'm trying to do that, but like in an independent question like this, it doesn't really help. So you don't have the data, yeah. So, well, it says you like a random sample of 100 for each group.
Yeah.
I think that's why I determined a pair, because it was 100 per each. So I think that's where I went with the paired sample, because it is an equal sample.
Yeah.
He also said if it's from the same population, that's also how you determine if it's paired or not. So, they're both students and stuff, so that's same population. But he said if they're
school or what class, if they
yeah, like there's like a real estate one that threw me off on the homework one. But like he said, if it's like a set, like if you're studying data from 2 different states or something like that, but like the same, like that's independent. I don't know. I'm so confused. So.
Okay. Well, if we come across any more, we'll hopefully there'll be some more on this question.
Okay. But if you guys both think it's independent, I'm going to go with that because I get confused on these and get them wrong. So. Okay, 15. I got D for this, but let's see what you guys think.
I got D too, but let's reread it. Okay, an educator is interested in academic achievement by males and females with similar academic support systems.
They're brothers and sisters, so that's where I was like, yeah.
Would that be?
Yeah, that's
dependent.
Yeah, that's dependent, and then I put D because the brother, if you select a brother so as to compare his academic achievement to his sister, you must include the sister in your studies. So, yeah.
That's exactly right.
That one was pretty clear.
Yeah. The other one,
pretty clear.
Sister's academic depends on, to some degree, on their brother's academic achievement. They were comparing brothers to sisters, not sisters to brothers. That's the only reason that one's not correct.
So my only question with the prior one, oh, go ahead.
I was just going to say with the C, they're suggesting that the sisters' academic achievements have something to do with the brothers, but they don't, because they're not like comparing like what happens to the sister if the brother does good. They're just wanting to know what the brothers is compared to the sisters. They're not saying that the sister is dependent upon the brother or the brother is dependent on the sister. They're just comparing them. But that's what number C is saying to me, is that they're saying that if the sister does good, then the brother does good.
Right.
So that's my question from 14 is if you use the same logic, you're wanting to compare males and females, then you'd need a female to compare to a male. Like it'd be dependent in that way, wouldn't it?
Yeah, but it doesn't.
To a sense, yeah.
but it doesn't tell you, because you pick a male, it doesn't tell you who the female is going to be.
Okay.
Yeah.
In
In this
one,
subject, because you picked the brother, you have to pick the sister.
you know
Yeah.
exactly who the girl is going to be. It's
Okay.
Yeah.
his sister.
Okay. Okay. All right. So we're all in agreement D for that one. And so 16. Oh, I didn't even mark that.
I didn't either. Okay, 95% confidence interval for the set. We're going to have to open this one up. That's why I didn't do it.
Oh, I did this one. I just, I was saying I didn't mark the last one for what we were discussing. Okay, yeah, go ahead and do this one. I have my answer for this one.
Oh, I'm sorry. I was looking at 16 already, too.
Okay.
So for 15, I got B. Because we don't know what the...
D for the brother and
No.
sister one?
For question
15 was...
15 or 16 in a book? Or
Oh,
on
in the book, which is question...
Yeah. 16. So the next question that we're doing, right, is...
Of the types of confidence interval, yeah, the soil scientist, yeah.
And I got B, or the second one, because we don't know what the standard deviation is.
Yeah, I think I got B for this one.
That's what I got.
Okay.
Does that sound right to you, Phil, or what did you get?
I didn't know this one.
Because the only information that we're given is that there's a 95% confidence interval, and they want us to open up the data file, which we're going to have to do anyway because of the next question.
Uh-huh.
So let's just open it and double check.
So it's like the confidence interval for the mu when the sigma is unknown, which
Yeah.
is the single t-test, isn't it?
What was this called? Dissolved organic carbon file.
Mm-hmm.
Yeah, I'm trying to pull this up too. Sorry.
Okay, so yeah, and it's just going to give us a bunch of numbers from each of the samples. So it's definitely, we don't know.
We don't know what the sigma is, so it's unknown.
Yeah.
Yeah.
So
Okay.
on the next
Okay.
one, we have to plug that into.
Mm-hmm.
So now we're just doing a one sample t-test, right?
Yeah. Mm-hmm.
We don't have like multiple.
We don't have multiple means. Yeah, just one.
So if we plug it in though, oh, it gives us a standard deviation, but we didn't know that before the test. So yeah,
Right.
I think it's got to be for the
Yeah, I mean it's the confidence interval because we don't know them for any of the ones after that first, the z-test one. Like that's the only one where the sigma is known,
yeah.
and after that everything is t-test and paired sample and independent and dependent, and then the ANOVA. Those are all unknown sigmas.
Oh, that's true. Okay, so I got.
Oh, I got the last one.
That's what I got too.
That's what I had too. Yeah.
Keep forgetting to mark it on my sheet here. On my, so 11. Okay. Moving on.
Okay, so this one is where I think I got it wrong of which test to use, and because I still don't get how you tell between the paired and the independent and dependent. And the only reason I realized that I was wrong is because of, because it didn't show up in question 19 here. So anyway, so I went back and changed my answer for that one.
So a random sample of Hummers for sale in Los Angeles and New York were taken from a listing at cars.com. We want to know if there's a difference in listing price between Hummers for sale in Los Angeles, Group 1, and Hummers for sale in New York. Group 2. Create a 95% confidence interval for the true difference of means listing price between the two cities. So because it's asking for the difference, we know that it's going to be the paired.
Okay.
But how is that?
But it's not, because it doesn't show up, and that's what I thought. That was exactly my reasoning, and then it didn't show up in 19 when you use the paired sample. It doesn't show up.
Okay, of the 4 types of confidence intervals listed below, which is appropriate? Well, we know it's not the first one because the confidence, we don't know what the mean or the.
Yeah. And there's a couple of different columns, so it's not A or B. I think it's
It's got to be the interval difference.
It's either C or D, but I went with dependent, and it was wrong.
Dependent? What do you mean? Oh, well, they're definitely not dependent though.
Well, but you said because it's the difference, it'd be the paired sample, which is dependent.
Well, no, not always. You can have paired samples that are not dependent.
Okay.
Go back to your flow chart. So for this one, they're not dependent because just because you pick a car in Los Angeles, it doesn't tell you exactly which car you're picking in New York.
Mm-hmm.
Yeah.
I mean, we know they're going to be Hummers, but it doesn't tell you which Hummer it is. Do you know what I mean?
Yeah. It would be the same thing as saying like you're picking boys in LA and boys in New York. Just because you pick a boy in LA doesn't mean which boy you're going to pick in New York.
Okay.
Another boy, right?
Okay.
And it can't be the first one because there's more than one sample.
Yeah. No, I knew it was between C and D, but this is one that I picked. I think I picked C at first, the dependent sample, and then I went to 19, and I'm like, nope, that's the wrong test. So I went and changed it to the D.
The other thing that I'm just catching too is in the question it says we want to know if there's a difference in the mean listing price. And so the confidence interval for the difference of means, that's worded the same way in option D, whereas the C it says you're looking for the confidence interval for the mean of differences. We don't want to know what the mean of the differences are. We want to know what the differences of the means are. Does that make sense?
Okay.
Could have caught it that way too.
Okay, that's a good point. So I'll see if you guys come up with what I got in 19, or on question 19.
Oh, yeah.
I lost it. What did we pick on 18?
So it's just the last one.
It's the confidence interval for the difference of means using independent samples.
Okay, cool. All right.
Yeah. Yeah, I mean, that's what I determined, but it's only because I couldn't find the answer doing the other test in question 19. So I'm like, oh, yep, I was wrong. Once again.
I need to put this in. I haven't worked this out yet. Oh wait, so this is just using the formula. We don't have to use a. So the formula that you used then was for unknown confidence interval. So X bar plus and
no, for 19 you're using the two sample t-test in the inference document, and you're just plugging in the numbers from that thing.
Is there a Hummer thing then?
Yeah.
Yes.
Okay.
Yes, there is.
It says open the data file, used Hummers, LA, and New York.
Okay, let me open.
So you just copy paste those into the independence, the two sample t-test.
Yeah, that makes sense.
Mhm.
Okay. Oh wow. So we want what are we comparing? The price? Do we want the price column?
Yeah.
We don't want mileage. And we have to divide them by. Do they list Los Angeles first? Holy cow, there are a lot.
Yes, I do.
And I guess this is another one, like the one column Los Angeles is a lot more than New York, and so that's another one that was like, oh yeah, this would have been independent. So that kind of led me to that, but yeah.
I got my answer.
Okay, hold on. I'm still pasting. I'm almost done though.
The only thing that threw me off with this one, Phil, is that they didn't have in the answers the decimals, but they just rounded it all up to the whole number. Did you notice that?
Yeah, I did. And I was kind of wondering about that. I was like, I hope I'm doing this right.
Yeah.
But no, yeah, it's both of those round down, so.
Okay. All right, so I'm getting the third option. Is that what you guys got?
Yep. Negative 423 and 5417.
Mm-hmm. Yeah, that's what I got.
Okay. So now we have to open exercise bone density.
Mm-hmm. Okay.
The first two.
Oh my gosh.
Okay, so
When will it end?
I know. Oh, wait, is it exercise. Okay, so many studies suggest that there is a link between exercise and healthy bones. Exercise stresses the bones, and this causes them to grow stronger. One study examined the effect of jumping on the bone density of growing rats. There were 3 groups. Rats selected at random for the 3 groups: a control with no jumping, a low jump group, and a high jump group. After 8 weeks of 10 jumps per day, 5 days a week, the bone density of the rats, expressed in milligrams over centimeters, were measured. The rats were selected at random for the 3 groups. Researchers would like to perform a hypothesis test to determine if the mean levels of bone density are different between the 3 different groups of rats listed above. Use a significance level of 5. Open the file. What is the correct hypothesis test for this situation? So there's 3 of them, so we know it has to be either ANOVA or
It is, yeah, it's 3, so it's ANOVA.
yeah, because you can't have.
You can't have more than 3 for any of the other ones.
Yeah.
I mean, more than 2. Excuse me.
I knew what you meant. But, okay. Okay. We have ANOVA, and then calculate the test statistic. Okay, I'm plugging in information. Did you already get it, Phil?
No, that's what I'm doing right now.
Okay.
I've got my answer from yesterday, but I'm just redoing it.
Oh, we want low jump.
So it was ANOVA E for 20. And
Yeah.
Okay.
Oh, wait a minute. So we have the control, the low. Oh, I just did that wrong. So we have the control group would be 1. Right? Is that what you guys are doing?
Yeah.
Yeah. I just kind of did it in order.
It's a test. Oh my hell.
I know, I hate that.
The TS for a ANOVA test is the F, right?
Yeah, the test statistic is F for ANOVA.
Okay.
Okay. So I got So would we do, which one are we doing? So the test statistic,
The test statistic is first.
but what, I'm not getting anything close to any of those numbers.
Oh, okay. Did you clear content for the other columns?
I did.
Hmm.
So wait, so I have for my test, for my DF, because that would be the test statistic, right?
No, F is
No,
the
it's
test
just the F.
statistic.
Oh,
Just the F.
okay. Okay, I'm still getting something different then. Okay,
The
so
DF is the, what is it called? The degrees of freedom, and that would be 2 and 27. Yeah, you have to do 2 and 27 for that. So, okay, yeah.
So what did you guys? Oh, I duplicated my column 1. That's why.
Oh, okay.
Hold
Yeah.
on, that's not
They
right.
should be all. They should be all equal.
Okay,
That'll
so
mess up your numbers.
yeah, I'm getting the 7.978.
7, 8. Yes.
Okay. Okay. Okay, and the p-value. Do you guys get the 0.002?
2. Yes.
Yep.
Okay. Which of the following best expresses the conclusion for this test? Well, it's a lot less, so we would reject the null, right?
Yeah, there is sufficient evidence to conclude that the bone density of at least one of the groups is different from the bone density of at least one of the other groups.
So the second one.
Mm-hmm. And the reason why is because the null hypothesis is that they're all equal, and then the alternative hypothesis for ANOVA test is that one or more of the groups is different than the others. So.
Okay. But they were all roughly the same, right?
Yeah.
Okay. For 24.
Oh my gosh.
Yeah, this is the one that I have the question on and that I want to talk to the teacher about, because when you enter this data in, it has blank spots. And when you do the difference, because this is a paired sample, so when you do like the difference and stuff, it just messes up the numbers. And so
What you have to do is you have to just go clear them. Don't put zeros, but just clear them.
Yeah, well, I did that, but it's still, even for, and this is one that I didn't know, but even like when you have like one column has a number in it, but then the one next to it does not, you have to clear out that difference as well. Like you can't calculate a difference for that. So like if it's like 300 in the first column and then the second column is blank right next to it, you know, it would usually do like the difference is 300, but you can't have that number there. It messes up your entire test.
Let me open it up and see if I'm running into the same thing that you're saying.
And I think that's what was throwing me off in some of the quizzes, is because, you know, you get these with the blanks and I clear them out, but then, you know, it would still have an off number.
Hold on. So I'm looking at direct. Okay, well, so for the first one, what's the correct hypothesis?
It's the dependent sample t-test, or, yeah.
Because it wouldn't be ANOVA because there's only 2.
Yeah.
And it wouldn't be, oh, wait a minute. This is the lowest published, oh yeah, and it couldn't be independent because if you pick a flight going to one destination for the 14 days, you have to pick the same flight going to the same destination for the 90 days to do a comparison.
In a 90-day advance, yeah.
So yeah, dependent sample test. And then I need to open it up.
Oh, crap.
So we want, so this is going to be a paired, right? Paired sample test.
Mm-hmm.
And I'm plugging in my information. So are we doing 14-day first then?
Yeah, that's how I did it, yes. I'm going to do my difference really quick here. And they said it doesn't matter which ones we do first, right? And these ones?
Well, it has to do with how you're reading it. But if we don't change anything, this is fine. Change the formula. That's what you're using last time.
Mm-hmm.
Hey, how come I'm not getting a difference?
Hold on. I'm not. My.
Start over.
I can't get out of my. I messed something up and I can't get out of it.
Could you just press escape if it's like still trying to copy?
That's what I think that must be what it's doing. Hold on, let me try that. Okay, thank you.
You're welcome. I just learned that the other day, so I wish I knew that 2 weeks ago.
Yeah. Okay. Okay. So, after, yeah, that's weird. Why is my, so when you, Phil, when you were not getting a difference column, was it just some of them, like the first ones?
No, I wouldn't get any of them.
I'm going to reopen this too. I'm getting
And this is a level of significance of, let's see, 0.10, so it should be changed to 0.90 at the top, just to let you guys know.
All right, I had to reopen mine altogether, so hold on.
Okay.
Because it was doing something funky.
But yeah, this one really copies. If you just copy and paste it, it makes it really funky. So you have to go down like in column in number 16, cells variable 2 and difference. You have to make sure there's nothing in either one of those. They put a 0 automatically in like 57, line 57, and they also put a difference in line 40 when there's nothing in line A. So you have to go through and like erase stuff. It's pretty annoying. And I would have no idea if we had to just write in a number. You have to.
Right, you wouldn't have not caught that.
Yeah, except for it was multiple choice, and I'm like, yeah, none of my answers are on here. But both that David guy that comes to the meetings and I were having the same problem with some of these data that you pull up. You know, you enter it in and it doesn't enter it exactly right, and so you have no idea.
What? Okay. So I thought I did what you said, but I'm not getting the right answer.
Okay.
So where there's not 2 airports or 2 flights,
Yeah.
you have to just leave that blank.
You have to delete it. Yep. Just you don't want zeros or anything in there.
You keep the first variable. If there's like one flight that has a number and then another one that doesn't, I mean, you leave the flight that has it alone, but you have to make sure that the difference column and the other variable column is clear. That there's nothing in there, no zeros, nothing.
Oh, okay.
And then there's one that there's not a statistic in either column, either variable 1 or variable 2. It's line number 57, I think. And you have to make, and it puts a 0 automatically in the difference column. You have to get that 0 out of there.
Okay.
And then there's one down below that has one in variable 2 but nothing in variable 1, and you have to make sure there's no difference. Yeah, it's pretty annoying. So.
Okay, I am not getting a difference on the first few. I don't know why. I've redone it now like 10 times.
Which ones?
And I'm just not getting it. So the first 1, 2, 3, 4, 5, 6, the first 7 variable comparisons, I'm not getting anything in the difference column.
Okay, so in the spreadsheet, I just add an extra column next to the two lines of data, and at the very top line, I put equals, and then I take the one column minus the second column, and then you just do the crosshairs on the corner, and you just pull it all the way down, and it will calculate it all the way down.
Let me try it. Let me try that.
Yeah. And that way you don't have to go through each one and do the subtract, you know.
Equals.
That's weird. It didn't put zeros in.
For you, it didn't put zeros in?
No.
It didn't for me the
But I'm
last
still not getting.
It just does it in that one. It just does it in that one spot where there's no data in either variable A or B. It puts a 0 in the different spot for that one. That's the only one that it put a 0 in. But it does calculate a difference all the way down. So you just have to make sure there's no difference if there's no information in one or the other, or both.
Okay. So I'm getting, I think I'm getting a 1.636. And that's not one of the options. So what are we doing? What am I doing?
That's where you have to erase those zeros if there's a 0 in the difference column for.
That's what I just did. But
and make sure that there's no difference calculated for one where there's one in one column and one in another. Make sure there's no difference. So that has to be emptied as well. And then that should give you a test statistic of 1.685. And it should be confidence level of 90. Make sure it's 90. Yeah.
90. And we're doing not equal to, right? Yeah, because we don't know if it's more expensive.
Yes.
Come on.
Okay, yeah, now I got 1.685.
Okay.
So you got? Bill, are you getting that? Or what are you getting?
Yeah, I have a I got that, but my confidence level's at 0.95 and it won't let me change it. But I'm 0.9. Oh,
Well, the
that doesn't change. Okay.
level shouldn't matter for this.
It will matter for the next one though. Yeah.
Yeah.
The next one is 25, it's 26 in the quiz. It should be the B one, which is 0.96. 0.96, yeah.
Yeah, that's what I got.
Okay. And I hope these are right. I hope it's not like just one little thing and it's one of these other, ones in both, but I think it's right.
I think
I don't think so.
it's right. Okay, so 1.685.
Mm-hmm.
0.096.
96.
Okay, which of the following best describes
The conclusion or the expressions of the conclusion of the test? So I could put B to reject because the p-value is 0.096 and the alpha was 0.10 or so 0.096 is less than 0.10, so you would reject, and it would be there is sufficient evidence to conclude that there is a difference in the cost of tickets purchased 14 days in advance compared to 90 days in advance.
Because when you reject, it's
That
always
means yeah, because you're rejecting the null. You're saying that the alternative hypothesis is true, or that there is evidence to support that. So.
Oh, hey, that was it.
Okay.
I want to go back and make sure that I didn't not put something in.
Yeah, I'm doing the same thing.
So, were there any that we were kind of wobbling on?
I don't think so. I was confused about paired and dependent, but I came to the right conclusions, I think, because I got the same things you guys did, but I'm just trying to understand that better, but that was the only thing, I think.
All right. I think we're...
I totally wish we could take exams together.
I
know. We would do a lot better.
Just to balance
Okay.
off each other.
All right, submit.
Hunter!
Oh, that always makes... I'm always...
Yay!
with it. Okay, so we'll want to copy this. And, I don't know, I'll go over it again before we take the actual test.
Well, it seems like they throw in the test stuff that you're not really prepared for. So, like, I don't know. It seemed like the last one, there was stuff on there that I was like, I don't even remember.
Did we cover this? Yeah.
Yeah.
All right.
Yeah, like there's like little things. Like I think it was like, was it the margin of error or something that you're always supposed to round up, and there's like little rules that I'm like afraid they're going to test us on, and I'm not going to have it written down, and so I'm not going to be sure.
What was that one that we were always rounding up on? I don't think that was the margin of error, though. I think that was the...
What was that?
It was it the DF or something? It was one of those other little ones. I think it was the DF.
Well,
yes.
we never...
It's always going to... The DF is always going to be a .00 some zeros. So they always just tell you... Oh...
No, it was something else that you always go up, even if it's like should round naturally to like a lower number. You always round up to.
Yeah, I want to remember which one that one is too.
Yeah.
All right.
Yeah,
Are you guys going to try and go to the meeting today?
Yeah.
I think I will too.
I'll be babysitting, so I'm not sure if I'm going to make it because he's one and he's everywhere. So.
Are there any questions? I'll be a little bit late, but are there any questions that you guys want me to ask? And then I can email you the answers if you don't get a chance to listen to the whole thing.
I think I'm good.
Yeah, I think I'm okay. I again, it's just like little simple things that are going to screw me up. So it's not that I don't get the concepts. I think it's just, yeah.
Okay. All right. Well, good luck, everybody.
All right. You too. Good luck.
Okay. We'll see ya.
Okay. Bye-bye,
Good luck.
guys.